Good morning and welcome. My name is Steve Mann.
My name's Nishant.
Aiden.
My name is Aran.
And we're here to talk about Mersivity. We're here to talk about our exercise ball and the use of the ball for spinal rehabilitation. I've got a back injury and I use the ball for spinal rehab. And so we have a system that senses the orientation of the ball and puts it in like a virtual or extended reality game of sorts, gamification. And so the idea is that you balance yourself in the ball. So what we do is we walk on water in the ball, and walking on water is a matter of balancing. So like when you're walking on a tightrope, you have to stay balanced from left to right so that you don't fall off the tightrope, or when you're on a slack line or a skateboard or anything like that, or a paddleboard. With the ball, you can tip in any direction, front, back, left, right, diagonally. So it's kind of like walking on a tightrope through a four-dimensional space in some sense to begin with. So it's a good exercise for the spine, and then we gamify it by sensing the orientation. And so we sense how much tilt there is on the ball and what its orientation and position is, using both computer vision as well as an IMU, an inertial measurement unit.
Well, generally we've used an ESP32 to achieve this. As you know, calculating quaternions used to be sort of challenging. These days it's sort of a lot easier. We are converting quaternions to Euler angles and visualizing them to see the position of the ball without the gimbal lock.
Computer vision is also an important part of it.
Yes. So in order to evaluate the accuracy for our IMU, inertial measurement unit, we use computer vision to track a Ruko tag marker on the ball so that we can compare the accuracy of the IMU with the tracking accuracy of the Ruko marker. We make sure that a Ruko marker is mounted firmly with the correct orientation, and we calibrate the orientation before we conduct the experiments.
And so what we often do is we have a vision system that tracks the position and orientation of the ball as well as the IMU. And this allows us to create a gamified computer-generated world using absiment, which is like the area under the time-distance curve. So we have a known trajectory, a desired trajectory, and we try to make the calimpograph match. So let's say, for example, while I'm exercising, I try to walk in a perfect pattern, a certain prescribed pattern, such as, for example, a figure-8 pattern, or maybe a heart shape or something. I try to draw some specific pattern using calimpography and monitoring my target position and the actual position. And then the absiment is the area under the time-distance curve, which is more or less integrated error, distance from between desired and actual. Step from my towel. I'm going to step into the opening. 1 foot in, other foot in. Here.
Is that good?
Yeah.
Sorry.
So you can see, I'll just give a quick little test run.
Talk about a workout, eh?